Welcome to part 2 of the IPFS series. In the previous video we talked about all of the technologies that make IPFS what it is today, which is basically a distributed file system that aims to connect all peers to the same system of files. Kind of like one giant BitTorrent swarm, using the peer-to-peer system architecture. So this video is going to be a little different. In this video we'll be using the IPFS command line interface to interact with the network. I assume you have IPFS installed, but if you don't, head over to ipfs.io and download it. Go IPFS is the client you'll want. After you've downloaded IPFS, go ahead and type IPFS init in your terminal to initialize your node and make an IPFS repository in your home directory. We'll start by looking at files on IPFS, which is really core to the whole system. Here you can see a list of commands that have to do with IPFS files, and we'll be going over them one by one. So the first command is to add a file to our local node. We use the command IPFS add. You guys can follow along in the terminal. So I'm gonna create a file, a txt file. It can be any file you want, but I'm just gonna, use a txt file. And I'm gonna put some text in it. So let's look at the file with cat. And as you can see, it says test file. Now let's add that file to IPFS. So IPFS add test.txt. And the hash it returns, so this one, is a content identifier of that file. And the content identifier of a file is a cryptographic hash function of the file's contents. It's a unique identifier. So I've explained this in the previous video, but if I were to change one bit in the original file, its hash would change as well. Let's now read out the content with IPFS cat. We use a CID or content identifier to cat the file, and it will print out its contents. So like this. And again, we get this file. If you wanted to download the file on your machine, you would use IPFS get instead. But we'll use IPFS get later. So this was just simple adding, but what if you wanted to include more info about the file? Perhaps you'd want the permissions and file name or file size to be included as well. To do this, you'll have to add the W flag to IPFS add. So IPFS add W, and we do test.txt again, and the W flag stands for wrapped. So if we do this, we get back two hashes. The first one is the same as before, so the CID of the content of the file, but the second hash is basically the directory and file name information that was wrapped around the file we added. We can now use IPFS ls-v for both on the directory hash. And in it, you can see we have the file with the size and a name. Now, you can also traverse down the file path, just like you would with a normal directory, to display the file. So instead of doing IPFS cat directly on this hash, like this, on this hash, so IPFS cat, like this, you would do IPFS cat, and then you'll take the directory, and you would traverse down it like this. So pretty intuitive file searcher. If you've added a file to your node, you have pinned the file to local storage, meaning that it's now permanently on your system unless you delete it. To see all your pinned files, you can use IPFS pin ls. So here we go. IPFS add automatically pins things for you. So you might be wondering what this command is used for, and this becomes clear when we talk about going online. Imagine you want to read the IPFS whitepaper, which is hosted on IPFS, and maybe you want to keep it on your system so you can help other peers on your local network, for example, find it more quickly. You would request a file from the network using its CID, and the way this works is the file is now cached locally, so you can see it, but it's only cached for a short while. It will get deleted from your cache after a couple of days. So to prevent this, you would use IPFS pin and then the hash of the file. Everything we've done so far was all done locally, so we didn't really have to connect to the network. Let's now actually go online and connect with other peers. So it's important to note that, in short, IPFS works on top of any network. So this is a picture of possible IPFS stacks from an official presentation by the founder of IPFS. So to go online, we'll start up the IPFS daemon in the background. So IPFS daemon and then the ampersand for background process. And as you can see, it says initializing daemon with the IPFS version and all the other info. Okay, so now that the daemon is ready, we'll just do that away. Alright, so the daemon is a software that communicates with the IPFS network so that we can add and retrieve data from it. We'll work with the IPFS whitepaper as an example. The first thing we can do to get the whitepaper is through the CLI with IPFS cat. This time our node will actually ask the network for the file and retrieve it from the peer or peers that have it. So yeah, you can find the hash of the whitepaper in the description and you can copy it and use it. So I'll do this. And since we don't have this file locally, I mean I do, but you guys don't, it's gonna ask the network for it and retrieve it through the network. But as you can see, it's all just a bunch of random binary data. So yeah, the binary data makes up the PDF. So we'll put that into a PDF file. So let's do IPFS cat this again, and we'll do that whitepaper.pdf. Sorry, the auto completed. And now we'll look at the whitepaper, and as you can see, this is indeed the whitepaper we wanted. The next and arguably better way to get the file is through your node's HTTP gateway. So the gateway is listening on a local host on port 8080, so localhost 8080. And a valid URL looks like this. You add the method you're requesting the content by, which will either be IPFS or IPNS, which is the interplanetary name system, which I'll talk about later. And then you add the hash. So in our case, we'll be using IPFS and then the hash. And it now retrieves it through the gateway of our node. The final way to access content is on IPFS is through public gateways. So the IPFS project has its own gateway at ipfs.io/IPFS for the method. So, and then again, we use the same URL structure, and it gives us the IPFS whitepaper as well. So this is the best way to retrieve data from IPFS if you don't have your own node, although it can sometimes be very slow. So if you'd like to show something you've added to IPFS to your friends that don't have their own nodes, they could look it up through a public gateway. So this is the official one, but there are a bunch of other ones. So Cloudflare has their own gateway, which is cloudflare.ipfs/IPFS, and we'll look up the whitepaper again. And then I know of one other one, which is ctheris.io/IPFS/whitepaper, and there we go. Now the reason that public gateways are slow, this wasn't slow because I mean a lot of people look up the IPFS whitepaper, so it's cached to those nodes already. But the reason that it is slow is that the node behind the gateway has to first retrieve the content from you if you've added the content yourself. And since a lot of people use the gateway, it can kind of be a bottleneck. Now if you want your files to be easier to access to outsiders or something, I don't know, you could use a pinning service. And a pinning service is basically like someone with a bunch of servers or computers, and they take your hash. I mean, you have to pay them for it, but they take your hash and they pin them across all of their computers. Now the one I'm using is Pinata, and your first gigabyte was free, so I mean it comes in handy. And like for an example, I've put my GPG public key on their pinning service, and this one is unique, so normally only I would have it, and it would take a bunch of time for public gateways to retrieve it from my node. But since this one is hashed, is pinned across a bunch of computers, it won't take long to access it through a public gateway. Now the reason I've put my public key up here is because you guys are gonna need it in the second part of this video. Alright, let's go back and look at the startup messages we get when starting the daemon. Okay, so we already know that IPFS can work on top of a lot of networks, and that means that just as with the multi-hashes, the formats need to be self-describing. This is why IPFS uses multi-addresses for network addressing. You can see the multi-addresses of your node at the daemon startup. So here are a bunch of nodes with the classic TCP/IP model. So these start with an address protocol code followed by an address value. So here you can see that. And this then repeats itself till all of the protocols are included. So now that we're online, let's try checking the peers we're connected to. I'm gonna open up a second terminal, zoom in a little. So the command we're gonna need is IPFS swarm peers. Okay, so since my daemon has just started up, it's still looking for peers to connect to, so we've now only got 2 of them. But as you can see, this returns us a list of even longer multi-addresses. So the first one was, the protocol was IPv4, then we have the address value, then we have TCP, and port value 4001, then we have IPFS, I'm sorry, and then our node ID. I mean, not our node ID, but the node ID of the person we're connected to. You can hopefully start to see why these are useful. Let's inspect one of those IDs with IPFS ID and then the value. So I'm going to use this one. IPFS ID. There we go. Alright, so here you can see the ID, which is it's just the multi-hash of that peer's public key. And then you can see the multi-addresses of that peer. Another cool thing that IPFS comes with is a web UI, which you can use, which you can access through localhost on port 5001, and then /web UI 5001 /web UI. All right, so in here you can check your node status, your network traffic. You can even add files graphically, so this, and then you can check your peers and where they are in the world. So right now I'm connected to 67 peers, and this number will increase the longer my daemon was running. And you can identify them through their multi-addresses. Let's sidetrack here a little and talk about security on IPFS. Mainly how to add sensitive content to IPFS that's meant for only certain people to see. So since there's not really any built-in security, meaning that if someone has the hash of your file, so the content identifier, they could just retrieve it no problem, it's not that ideal for sensitive data. Maybe healthcare records or bank stuff, I don't know. So since asymmetric encryption plays a big part in IPFS, and since it's generally just a very interesting topic, I thought I'd explain it through an example. Let's say we have a sensitive PDF document, I'll take my CV as an example, and we want only certain people to see it, maybe my boss or something. Let's call him Bob. Asymmetric encryption allows us to take someone's public key, in this case Bob's public key, and encrypt the document with that key. So only the intended recipient has a corresponding private key that can decrypt the document, so only Bob can view the contents. So this was an extremely short explanation of asymmetric encryption, but I've put a link in a description to a very good video that explains it a little more in depth. Let's now do this in the terminal. We'll use GPG, which is the GNU Privacy Guard, for our purposes. So make sure you have that installed on your system if you want to follow along. I'm gonna do things a little differently. So instead of taking one person's public key and encrypting it with that so that only one person can decrypt it, I'm gonna take my private key and encrypt it, and encrypt the document with my private key so that you guys can take my public key and decrypt it. Keep in mind that this is not secure since everybody has access to my public key, and normally you use the keys the other way around, but this is just to make a point. So I have some keys on here which I can show you with GPG list keys. Okay, so I have only one key, but yeah, you can use your key to sign your document with GPG-sign, and then I'll take my CV, and I have to put in my password. Alright, so now we have a PDF that's encrypted with a GPG private key. The next step is to put the signed document up on IPFS, which we'll do now. So IPFS add cv jonas.pdf.gpg. Okay, so I've started up a Windows virtual machine to demonstrate that the next steps are on another computer, maybe perhaps even your computer. I'm going to be using git bash, which is a bash terminal for Windows, but you can also use Cleopatra for all the GPG stuff I'm about to do. Yeah, Cleopatra is just a graphical user interface for GPG, but I like the command line more. So So let's now take the hash of the document, which I'll put in the description, and do IPFS get to download the file with -o for output. We'll put it in CV polycode.pdf.gpg, remember, because it's GPG encrypted. And we paste in the hash. Okay. Alright. Yeah, so before you can decrypt this file, you guys will need my public key, which I've also put on IPFS. So we do IPFS get again with -o key.gpg, and then the hash, also in the description, by the way. Oh, I'm sorry. So do, I don't know how that got in there, but IPFS get. Alright. Now, so yeah, the last thing we need to do before you can decrypt the file is import my public key. So you have my public key, but it's not recognized by your GPG client yet. So let's do that. So GPG import and then key.gpg. Alright. And now we can finally decrypt the file. So GPG decrypt, what was it? CV polycode.pdf.gpg, and we'll just put that into CV polycode.pdf. Oh, it's the other way around. So first we need output and then decrypt. Come on. I'm sorry, guys. Decrypt CV. Alright, finally. Now let's look at this. So we have the PDF encrypted, and we should have the normal PDF. Yes, there it is. Alright, let's get back to the main thing. So until now, every time we talked about requesting a file from the network, we actually meant to query the distributed hash table for peers who have the file, then connecting to those peers and then downloading the file from them. We can also do this directly with IPFS DHT commands. The first one is IPFS DHT find profs, which queries the DHT for providers of a given file and then returns peers that have those files. So let's take the example of my encrypted CV and do IPFS DHT find profs. Alright, so since I've pinned my encrypted CV to a pinning service, this returns us a couple of nodes. Alright, so once we've gotten back a list of peers, we can also find out where those peers are with IPFS DHT find peer. Now all these commands happen under the hood. I'm gonna take, I don't know, this one. And this returns us all of the multi-addresses that the peer has opened to communicate with IPFS. Now this, yeah, I was saying that this all happens under the hood, which is true, but it's, I don't know, it's pretty interesting to find out how all of this works. The next thing we'll explore is Bitswap, which is a protocol responsible for exchanging data blocks. Remember that it looks a lot like BitTorrent, but in BitTorrent swarms are formed, while IPFS is more like one big swarm. I'll give an example of why this might be useful. So imagine two people wanted to download the same movie but in two different languages. They would join two different swarms who can't exchange data between each other, even though the movie might, for a very large part, be the same. With IPFS, data blocks can be traded cross files since large files are split up into objects that can be the same for a similar movie. To demonstrate some commands, we'll request a large file from the network, a video in this case. You can use the hash I'm using to work with me, which can be found in the description again. So this hash is the CID of an object that's part of a video that's been added to IPFS, although I don't think that the whole thing is hosted by anyone right now, so it's ideal to show you some stuff. We'll ask the network with for the file with IPFS get. Oh, and make sure your daemon is running in the background, because otherwise you won't be able to access the network. So we'll do that. And this creates an entry in our Bitswap want list, which we can inspect with IPFS Bitswap want list. So yeah, here you can see that's the same hash. Alright, so once we started downloading the file from the network, we can see the network stats we have with a certain peer. Alright, so I've been able to download the full file, and it turns out that it was actually a directory within it, the movie The Dark Knight Rises, which is pretty cool, you know, in HD. I mean 720p, but it's still good. Now, unfortunately, I wasn't able to find the peer who I downloaded it from, but normally you should be able to see it with IPFS ledger, IPFS Bitswap ledger, I mean, and then the peer ID of the person you've downloaded it from, and then you can see a bunch of stats. I'll just, you know, take an example, like exchanges, bytes sent, and bytes received. Let's talk about mutable files next. Since files added to IPFS are content addressed and thus unique, how would you go about adding mutable content to IPFS? For example, if you have added a static web page to IPFS but you wanted to update it, the new site would have a new CID that people don't know yet. So this is where the interplanetary naming system comes in, so IPNS. It's a system for creating mutable links to IPFS content. A name in IPFS is the hash of a public key. So to tell IPFS that we're looking for a name, we have to change the prefix from /IPFS/ to /IPNS/. Normally when you publish a name, the default will be to publish it to your peer ID. This is okay, but I think it's better to create a new key specific for your purpose. Let's look at IPFS key list to show our keys. So IPFS key list. Now the only key you should see is self, which is your peer ID. The way we create a new key is with IPFS key gen and then the name. So let's do that, IPFS key gen, and I'm gonna call it test. Oh yeah, I'm sorry. So IPFS key gen type equals RSA, and then we have to so the type is the type of the public and private key, and then size, I'll just take 2048, which is the standard one, and then we'll call it test. So if I now do IPFS key list again, you can see that I have two keys. Alright, so I've created a small HTML document, as you can see, and the first thing we need to do before we can publish it to a name is to add it to IPFS. So let's do that, IPFS add polycode.html. Alright, so we've added that. Let's now publish the page. So the command we need is IPFS name publish, and then as key we'll take our test key, and then the hash. Okay, so I have to copy it. Come on. Alright, and this can take a while, but in the end we should have a link that points to that hash, and every time we update our page we will republish it with the correct hash. Right, so this should be the message once it's finished. Now let's take this hash, which is the multi-hash of our public key of this one, so of the test key. Now I'm going to open up a browser and we'll search for IPFS.io, and instead of IPFS we now use IPNS, and then the hash that's corresponding to our published page. This can also take a while. Okay, so the page now loaded, but yeah, let's see the real power of of the naming system, the interplanetary naming system, and change our polycode.html file. So I'm gonna add just a second paragraph. Alright, and first we have to add this one again. Right, we now have a different hash. And then again, IPFS name publish key equals test, and then our hash. Okay, so we've now republished our hash to the correct interplanetary name, and as soon as I refreshed, the second paragraph showed up. Okay, so these links, they still aren't really human friendly, but at least, you know, they're better than a no content identifier each time. Now, there are ways to make these even human friendlier, and I'll put a link in the description to an article that tries to cover all these, but we're not going to talk about them in this video. So the last thing I wanted to talk about in this video was actually something I should have said in the previous video, and it's about the fact that IPFS is interplanetary. Take this scenario, which I've quoted from a Medium article. Imagine you are in a lecture room together with 100 people and you all watch the same video. What happens is that this video has to be fetched from the closest nodes of Google, streamed to each of the students' laptops and repeated 100 times. Instead of students who have an identical copy of the video sharing it with each other, we propagate large amounts of data long distances multiple times. Inefficient, but this is how HTTP works, and it's creating a large congestion problem on the backbone of the internet. Now, replace the lecture room with the planet Mars and the video with the whole web. It takes about 14 minutes for information to get to Mars, but instead of having to wait 28 minutes each time to get a server on Earth to send information to Mars, we'd only have to do it once for each piece of information, and the rest of it can be distributed among other peers on Mars itself. I think that's some pretty cool stuff, so I'm gonna end this video here. So stay tuned for the next video in which we're gonna build a Node.js app using IPFS. See ya.